Okay, recording is on. Since it's 2:06, sorry, this is UK time, different timing for you. I suggest we start. So just wanted to say welcome back, everyone, to PubliSHE. Nice to see you all again. So today is our last of our digital skills workshop, which will be focusing on image generation with AI, but in a responsible and ethical way. And I'm delighted to have our guest speaker from LSBU for this workshop, which is Tim Fransen, and I'm sure he'll say a little bit about himself in a minute. And so this is an interactive workshop, and after the workshop, we'll also let you know some of the future workshops and sort of next steps, including the day in April where Martha and I, the project lead, we're planning a visit to meet you all in person. So I'll talk a little bit about that at the end. And we also have a survey, which will be really, really useful if you could complete it at the end of the workshop. And this is to assess, kind of to have a feedback on this particular workshop and to inform how we organize the future workshops until the end of the project. So I'd be really appreciate if you could take the time to fill that in, and I'll put the link in at the end of this session. Okay, thank you very much, and I will now leave it to Tim. Tim, over to you.
Thanks, Clara, and hi everyone. There's still people landing, joining, so yeah. We'll maybe wait another minute or two, and then should I just kick off, do you think? Or
leave it a minute and then you can start. So we have 13 participants at the moment.
I think it was about 10 or so that accepted.
Yeah. And just for those who are just joining, if everything is in English today, but if you need Tim to maybe repeat some information or have a query, if you can pop it in the chat, and then I will be monitoring the chat and can give a heads up to Tim whilst he's presenting, because I don't think, Tim, you can see the chat whilst you're sharing your screen.
No, it gets all a bit cramped. Okay, so I'll make a start. I'll do it a sort of slow pace. So, and Clara, give me a shout if any repeats are needed. So this session, looking at responsible generative AI images. My name's Tim Fransen. I'm a technical tutor and researcher in generative AI, web publishing and graphic design at LSBU. I teach visual communications essentially in the schools of art and social science and the School of Engineering and Design. I'm also a member of the LSBU AI Working Group, which looks at policy within the university. I'm a researcher at the university's Digital and Data Research Centre, and also a co-founder of something called the Creative and Responsible AI Lab, or CRAIL for short. I've put all the kind of information for today's session on this web page. So there's various links and so forth, and we'll pop a direct link in the chat at the end. So just to start with, just a bit of context, I'll do a short intro to CRAIL. So CRAIL is a technician-led initiative within the university's Digital and Data Research Centre. Its aims to sort of foster innovation and best practice in both creative and responsible use of generative AI through practical workshops, talks, screenings, and public events. As illustrated here in this diagram, CRAIL is like I said a moment ago, is based in the Digital and Data Research Centre, and we work closely with two other entities. As you can see, there's crossovers here: XR Studio and CSNI, which is the Centre for the Study of the Networked Image. CRAIL has been developed with strong support from the Research Centre Director, Professor Jeff Cox. The XR Studio is a digital creation and research facility that supports academic research and creative businesses in prototyping and designing immersive and interactive products and processes. And CSNI is a long-standing research group in the School of Arts and Social Science that examines how network culture and computation shape the production and circulation of images. The CRAIL pilot, which we ran this year, explores how generative AI works and how it can be used responsibly and creatively across text, images, audio, and video. Designed for LSBU staff across disciplines and job groups, the programme is facilitated by creative technologists like myself and promotes critical hands-on engagement with emerging AI tools and systems. The programme aims to build staff confidence, develop AI literacy, and encourage reflection on ethical and environmental considerations. The semester-based pilot informs long-term provision and institutional strategy for AI creativity and education. If I just scroll back a little bit, you'll see on this particular web page there's a series of links and these sort of pulsating info buttons. So if I just click on this briefly, we'll open up on the CRAIL website, and you'll get an idea of the pilot program and various workshops, talks, and so forth that we have done over the past academic year. So you just click on a link and you'll find out a little more about that particular session, which in some ways this session feeds off this particular workshop delivered in February. Also, there's a YouTube channel. If you click on that, and you can see some recordings of the film screenings and talks that have been recorded. So what we'll cover in today's session will be, as you can see here, how AI generates images. We'll look at some definitions of used in artificial intelligence, like, for example, what is a model exactly, and so forth. We'll have a look at Stability AI, a UK company that produces something called stable diffusion models. We'll look inside the kind of black box of diffusion models, see what kind of components are in there. Look at some of the ethical issues surrounding it, and also things to kind of mitigate those. So things like copyright and IP issues, bias in AI image generation, environmental impact, and kind of finally going kind of local. So running things on your own devices, and round up with a short demo of a piece of software called Invoke Community Edition. So in terms of sort of ethics, it's not just about whether AI images are good or bad, but about responsibility, fairness, consent, harm, accountability across the whole image making process. So within CRAIL, what does ethics include? So consent, copyright, bias, labour, transparency, accountability, and cultural and environmental impact. So first up, I'm just going to play a short video about how AI generates images. This is by a designer and engineer. He does these short little videos, 2 minutes, 3 minutes long, which kind of get to the core of things. From a sort of a very high level, which you'll see when I play this, a diffusion model takes a prompt and some random initial noise, and iteratively removes the noise to construct an image. The denoising process is guided by the prompt, and once the denoising process ends after a predetermined number of steps, the image representation is decoded into an image. So I'm going to click play here.
This is how AI generates images, visually explained. Imagine you were a sculptor and someone asks you to make a statue. You would get a stone block and start chiseling away until you get your masterpiece. AI generates images in a similar way. It starts with an image full of random pixels and gradually adjusts them until you get the final result. But how does it do that? The process is called diffusion. These models are trained on billions of images with text descriptions. But machines don't see images like we do. They see them as grids of pixels, and each pixel is represented by 3 numbers for red, green, and blue. When you train an AI model on billions of images, it starts recognizing what words are associated with which pixel patterns and values. This creates a multi-dimensional map called the latent space, and it maps specific features like a shape, artistic style, or color to their pixel values and patterns. To capture all these fine details, these models are trained by taking each image and slowly randomizing all the pixels until it becomes pure noise. Then the model is trained to reverse the process to reconstruct the original image. So when you ask AI to make an image for you, it's replicating that reversal process by taking an image with random pixels, adjusting the pixel values based on the latent space until it constructs the image you want. As you can tell by now, generating anything with AI takes a lot of processing power, which uses way more energy than before. And I'll talk about that some more in tomorrow's video.
Okay, so super quick, but you can watch that at your leisure. And he has a whole series of these, which I think are really good for simplifying complex AI concept to help a broad audience engage with and demystify some of the hype surrounding generative AI. So just some definitions. When we say generative AI, when we say AI, there's traditional AI, and then there's generative AI. Generative AI is a type of artificial intelligence designed to generate content such as text, images, sound, or video. Next up, machine learning is an approach used to design and build artificial intelligence systems. ML is said to learn. I put sort of learn in quotation marks because it kind of doesn't learn like humans learn. By using examples in the form of data. I'm getting some, I'm not sure who's unmuted. I'm getting little kind of squeaky noises.
I'm trying to look, Clara, yeah. I'm trying to look. I can't see any mics open. Okay, maybe it's been fixed. Sorry about that. Keep going.
No problem. And so said to learn, and instead of executing step-by-step instructions. In other words, machine learning applications are big data driven. Each machine learning application is designed basically to solve a specific problem. In the case of image generation, the problem it solves is how to, from random noise and a text prompt, can a coherent image be produced? And it does nothing else. That's kind of what it does as a particular thing. And sort of, for example, a chatbot, a GPT, all it actually does is predict what the next token or part of a word or full word goes next. It has no context, no understanding. It's a statistical machine that predicts what the next token is. So a machine learning model is used by a machine learning application to complete a task or solve a problem. The machine learning model is a representation of the problem being solved. Machine learning developers use vast amount of data representative of a specific problem to train a model to detect patterns. The result of the training is a model which is used to make predictions about new data in exactly the same context. One thing to do with transparency when you use these tools, see if there's a model card. So a machine learning model card is a way of documenting essential information about the models in a structured way. Model cards are written by developers for both experts and non-experts, and are created during what is called the explanation stage of the AI project's life cycle to expose information on the model's capabilities and limitations in a way that is straightforward to understand. So I'll show you a particular model card for a stable diffusion version 1. If I click on that, this is kind of what they might look like. Developers don't have to do this, but in the interest of transparency, they should. It looks at things like maybe the misuse, malicious use, and limitations of it. And if we scroll down, bias in the model, things to look out for, how it was trained, some results on the training, and also very important environmental impact in the case of this particular model card. So, for instance, what we can discern from this information here, from the calculations provided by the machine learning impact calculator, that an estimated 11,250 kilograms of CO2 equivalent was required to train Stable Diffusion version 1. This is roughly the equivalent to driving a regular car with a combustion engine for about, we could say, 30,000 miles. So, and this is only about making the model. This was a relatively small model made in 2022, and models have got much bigger, and the impact in terms of electricity has got more and more as models have got larger and larger. Regarding definitions, you can find a further 31 explanations in a glossary that is part of Raspberry Pi Foundation. And if one clicks on that link, you can download a glossary of terms, really useful resource. So I think if we can get a commonality of language rather than marketing terms, it's really helpful in the conversation about these machines. So just a quick word on Stability AI, founded in 2019. It's a UK-based company behind Stable Diffusion, one of the most widely used text-to-image AI models. While often considered open source, it is technically open weight. So weights in diffusion models are the learned numerical parameters that store what the model has kind of absorbed during training and determine how it turns noise plus your prompt into an image. Some pros and cons of Stable Diffusion. Pros are open weight accessibility. So Stable Diffusion provides pre-trained models with Stability AI, provides pre-trained models with open weights via platforms like Hugging Face. This enables users to run, fine-tune and modify models freely, supporting kind of innovation and experimentation within the AI community, rather than proprietary models that you kind of like, things like Sora or Firefly, other tools that you might, Midjourney, for example, would be another. Energy efficiency. Stable Diffusion is optimized for consumer grade GPUs, graphics processing units, significantly reducing computational energy used compared to larger AI models. This makes generative AI more environmentally sustainable. Low financial barriers. Unlike proprietary models that depend on costly cloud infrastructure, Stable Diffusion models are freely downloadable and can be run locally without having to use cloud services. This lowers the costs for individuals, educators, researchers, and small businesses. Also advancing AI research. So Stability AI collaborates with universities and research institutions to promote open and ethical AI development. These partnerships help advance the field of generative models while maintaining a degree of transparency. Just a couple of cons as well. Potential for misuse. The open weight nature of Stable Diffusion, while empowering, also makes it vulnerable to misuse. It has been used to create misleading, harmful, or explicit content, raising concerns around content moderation and responsible deployment. And also copyright and other ethical concerns. So Stable Diffusion uses the Leon 5B dataset, has led to litigation in the UK, particularly Getty Images versus Stability AI at the High Court, concerning the consent using the use of millions of copyrighted photographs. So when these models have been trained, they've been trained on big scrapings of the web. So and these court cases are unraveling as we're speaking today. Furthermore, the Leon 5B dataset contains problematic material ranging from links to child sexual abuse content to hateful and private imagery, raising serious ethical and safety concerns about data provenance and the need for stricter curation. And we'll look a little later at possible solutions to that. Okay, next up, just going to have a little look into the Stable Diffusion black box. I'm just going to zoom out a touch. So we'll just go through this here. We'll start off with this particular diagram, and so this is a graphic interface into by a tool called Comfy UI, which allows you to build systems based on nodes. And so within a diffusion, to run a diffusion model, we have these little boxes here, as you can see. If I zoom in a touch more, and I'll just go through in a moment what these different nodes or boxes are. So there's, for example, here is our load checker. So this is the box that pulls in the model, where you select the particular model. And for here is something called the clip text encoder, and this is where you write your prompt. So you'll see these things when you use image generation, but they might be hidden behind a graphic interface. And this just shows us kind of the various parts of the machine, if you like. And so if I just zoom out a little bit, and I'll just quickly explain the A, B, C, D, E, and F. To the F is our final output. So the load checkpoint node loads the main components required for image generation. So the denoising model, for example, Stable Diffusion 1.5, the text encoder clip for our prompts. They could be positive prompts or negative prompts, and the VLA, which kind of decodes the image right at the end. So it sits just here in E and outputs the final image. B, the empty latent image node. This generates a random Gaussian noise tensor, which is like a multi-dimensional array of numbers used to represent image data, and sets the output image dimensions. So we've got our dimensions here of 512 pixels by 512 pixels, so a square image, and you could say quite low resolution in this case. And the batch size is basically how many times you'd like it to create an image. So you might set it to create 5 images and so forth. As previously mentioned, this clip text encoder node converts your text prompt, whether positive or negative, into numerical data that guide image generation and defines which features to include or exclude from the generated image. So in this case, I popped in clay golem from Jewish folklore. And then there's something called the K sampler. And this performs the step-by-step denoising process on the latent image, using guidance from both your textual prompt and model settings such as seed, which is for repeatability, and guidance scale for prompt influence strength. So we can see here there's this big long number here. This can be randomly generated, or you can type your own, and it's known as the seed. And there's a visualization of the seed just here. So this is the Gaussian noise. This is where it starts from, where your image starts. And so you create a random seed, could be any number you like, positive number. And when you run the model, it's you determine how many steps, how many iterations from random noise to denoising, how many denoising steps you want the machine to run. So in this case, I've asked it to do it in 10 steps. And this last one here, I'd just like to flag up, which is SFG, which is the kind of guide. It's known as the guidance scale, and that the lower the number, for want of a better word, the more creative or the more it ignores your textual prompt. So it's kind of like the machine being creative. I don't like to use that term. And the higher the number, the more it adheres to your textual prompt. There's usually a sweet spot. If you take it too high, you get kind of artifacting, and the images will look, if you want to keep it so tight to your prompt, you'll get peculiarities in the image. But sometimes it can be quite an interesting thing to explore in its own right. And so we're moving to the end of the steps. So this VAE decoder converts the denoised latent numerical data into a viewable pixel-based image. And why it does it, it does it in a numerical space rather than a pixel space, is it's more efficient. It would take a huge amount of time to not have this denoising process happening just with numbers and not pixels. And finally, once that node has done its thing, it outputs it as a image, a saved pixel image, which you can save to your local output folder for access and use. So I can just pause there if there's any immediate questions in the chat.
I can't see any at this stage, Tim, so I think go ahead.
Okay, thank you. So just go on to, so that's kind of like how the machine essentially works. Resolving some of the copyright and IP issues. There's certain things happening which are good, not released just yet, but there's public domain 12M, which is, and we have another link here. If I click on that, this is this repository of a data set of curated images. It's a high quality data set for each paired with synthetic captions using Microsoft's Florence 2 vision language model. So that's a model that can analyze an image and make a textual description. And it's created by Spawn company in 2024 and designed to support text to image AI training with minimal risk of copyright infringements. The images are curated from trusted sources, including Wikicommons, OpenGlam institutions, so galleries, libraries, archives and museums, and iNaturalist as well, and have been filtered for aesthetic quality, resolution, and safety. The dataset is open licensed under the CDLA permissive 2.0 license, and is hosted via Hugging Face, which we just saw, with captions and URLs to the images, and AWS's Open Data Image Hosting. PD 12M serves as a sort of legally and ethically robust alternative to these sort of web scraped data sets. So coming soon, there seems to have been a bit of a stall on this public diffusion model, also by Spawning. Coming soon, hopefully. So it is an open source image generation model trained exclusively on PD12M, ensuring copyright safe outputs. It's designed with ethical sourcing, transparency and adaptability in mind, making it especially suitable for open education, research and creative use. Currently in private beta, but I've got some examples just below to show you. The model is being tested and refined by early users. Built for fine-tuning and open distribution, public diffusion provides a responsible and legally sound alternative to models trained on copyrighted material. So just so you can have a little look, so this is an output from public diffusion and stable diffusion, and the prompt there here are another two. So both using exactly the same prompts, but there's a sort of clearly a different aesthetic to the outputs, and a few more examples, just so you can see what is hopefully down the road to feel kind of safer in outputting content and what the legal implications of that could be, and still unknown. This is just a video. I won't play this. It's a longer one. This particular designer and educator just talks about the public diffusion model. So he's quite a jolly fellow. So you can have a little look at that. And I've also added another recording, how AI unmakes images. So this was a recent talk at the Photographers Gallery, and the legal aesthetics of copyright. So the Photographers Gallery work with the Digital and Data Research Centre and hosted this particular event on the sort of creative and legal implications of AI generative images, featuring a couple of researchers, one a lawyer and one a creative artist, talking about. So the recorded talk examines how generative AI challenges established ideas of image making, authorship and copyright, focuses on disputes about AI image generators. The speakers argue that these systems dissolve images into data, complicating legal claims of ownership and raising difficult questions about fairness, creativity and artistic rights. So it's this idea that one just writes a prompt in what is a very complex system, and you get an output. The difficulty in claiming ownership is you've just really not contributed much to that output. So there's these kind of questions that this particular talk explores. Just going to flag up bias in AI image generation. So these are just some test kind of cards I have done either with students or just to kind of interrogate particular models, and they're quite simple tests. But for example, these are looking at Stable Diffusion 3.5 large turbo, which is a very big model, and just typing in the word professor and seeing what is generated, and we can see here a range of images of white men of a particular age, all seem to have glasses, and the model shows a particular bias with that particular word of what a professor might look like, and so there's no women professors for example. And just another one, just teachers, and here we see mainly white women and very young. So that's the so in a way my approach to using these tools is, and thinking about what the models are, they're kind of more like an infographic about the data set, and so the outputs are more giving you information about the data set and little more, so and we'll try some of these terms. I'll be doing a demo of a local-based tool or using a particular model at the end of the session. So AI image generation models can reflect and amplify bias presented in their dataset, leading to stereotypical, exclusionary or inaccurate representations of people, cultures and concepts. Bias can arise from imbalanced datasets, algorithmic assumptions or societal influences affecting diversity in AI-generated images. Addressing these issues requires maybe more inclusive data, ethical model training, and transparency in AI development to promote fairness and representation in generating content. Next kind of sort of ethical thing to consider is the environmental impact. And again, I've got this little short film which I think covers the issues, gets to the core of the issues. So there's basically, you've got massive data centers that require a lot of electricity, and the internet is kind of like the biggest coal run machine that humankind has ever made. So and also, as well as that, to keep these machines cool and running, it needs huge amounts of fresh water. So and also, which the short film doesn't talk to, but also the lived experiences of people around these data centers as well, which are thoroughly miserable. The extraction of water locally impacts on farmers and local communities. They drill deep, basically, and so all the wells that might be in existence dry up, and the extraction of water is a big problem. So I'm going to click play.
This is how AI uses water, visually explained. Every time you ask AI a question, that request is sent to a data center and processed by thousands of AI chips. Because the hardware in our phones and laptops isn't powerful enough to do it, these data centers need two things to operate. First, they need electricity to run. In 2024, data centers use 2% of the world's electricity, but this number is for all data centers that keep the internet running. We don't know what share of that can be attributed to AI alone. It's estimated that a single AI request uses 10 times more energy than a standard search. But this estimate is based on AI models from 2023, which are much smaller than the ones we have today. Second, they need cooling systems to prevent overheating. Most cooling systems use fresh water, and the average data center consumes 300,000 gallons of water every day, which is equivalent to 19,000 showers. And depending on the cooling method used, data centers may lose some or all of this water and need constant replenishment. Unfortunately, we don't have precise or reliable numbers for how much energy or water AI uses alone, because tech companies aren't revealing the size of their newest AI models. What we do know is that AI developments and usage are likely to keep increasing over the next few years, which will require more data centers, aka more electricity and water than before. Thankfully, some solutions are starting to emerge to make AI more energy efficient. And here are 3 you should know about. First, we could run AI on our personal devices instead of data centers because they've been getting more powerful hardware. This is called Edge AI, and we're already seeing signs of it. For example, the new iPhone can run basic AI features on your device directly without sending those requests to a data center. Another solution is called model distillation. The idea is to create smaller models based on large models to make them more energy efficient and cost efficient for your specific tasks. Because we don't always need the biggest and most advanced model if a task is simple. The same way we don't need a Formula One car to deliver a pizza. Finally, the AI chips and data centers are getting more efficient, which means they need less energy to produce the same output. Over the past 8 years, the energy cost to generate one token on an NVIDIA GPU went down from 17,000 joules to 0.4.
There's a lot of uncertainty around the energy and water cost of AI, but more people are investigating it now, and I found a couple of experts that I'm going to try to interview, and when that happens, I will post it here. See you then.
Okay, so another little rapid video, but very good. And the point about the big tech companies not being transparent with the costs, really, the environmental costs. I've tried and failed miserably to get even some high level kind of information from several of the big tech players, but you don't get any transparency there. So just thought I'd put some best practices for sustainability is using efficient AI models, choosing lightweight models. For example, Stable Diffusion Turbo, which basically has less steps to resolve the problem, so less computation. So I mentioned steps earlier, and some models might require 30 steps to get from noise to coherent image. Other ones might be able to do it in 4 or 5 steps. So efficient models, ones to look out for. Running on efficient, energy efficient GPUs. So using modern GPUs, so for example, the Apple M series for low power use. Using local processing to reduce water waste. So cloud, as mentioned, cloud data centers require heavy cooling. Local computers use less to none in terms of water usage. If you do use cloud services, pick ones that data centers are in cold climates, for example, Iceland, Canada, or Finland for low water use. Avoid unnecessary computation, so don't generate excessive images on cloud-based systems, and also using low res to begin with, and upscaling instead of doing full resolution renders as well. And powering AI with renewable energy, so using solar, wind energy for local GPUs or select green cloud providers. This just helps keep AI creative work sustainable and responsible. So solutions to sustainable tools, which was mentioned as edge computing in the short video. So a couple of tools that I'll just sort of flag up, and I'll do a little demo of Invoke. So Invoke is Invoke Community Edition is a free open source local hosted graphic interface focused on controllable AI image generation for creatives using stable diffusion or diffusion models and related generative models, with support for node-based workflows like the diagram I showed earlier, layer-based canvas editing, so in painting, so as well. And it's community driven, so it's built by a community of programmers, and all the coding is available to for software developers to develop the particular product. And that's just a screenshot of what the interface looks like here, which we'll have a little look further. And just to flag Comfy as well, I would recommend Invoke if you're just starting out, exploring. It's a very capable tool, and for image generation, and it only does that. Comfy is also another tool that we use, which is also free, so no licensing issues with the software itself. It's again open source, and for local based, node based graphical interface focused on building customizable AI image generation workflows using diffusion models, and it also supports video, generative video and generative audio workflows through extensions and custom nodes. This tool is a more complex tool, but I thought it would be quite good just to flag as well. And I will show a demo. What I think would be nice, while I just set up this end, if we have a little 5-minute break to rest the eyeballs and make yourself a cup of tea, and we'll reconvene in 5 minutes time, so 7 minutes past 3 my time.
Yeah, that's great. Thanks, Tim. See you in 5 minutes.
Great. Hello again. So I hope you had managed to make a cup of tea and had a little stretch. So to start with, I'm just going to not really expecting you to download it and get it all running, but what I'll do is show you kind of where to kind of go, and then show you the workspace of the tool. So I'm just going to click on that little info graphic, and so this is the Invoke.ai is where you can download the software. Very straightforward. Depending on the operating system that you use, you can download the Windows version or the Mac or a Linux version, depending on your particular systems. You kind of need a machine that's at the very no more than 5 years old, really. It needs to be a machine that is kind of in line with when the technology became mainstream. So ideally within the last 3 years, but the machine I'm going to demo it on was 2020, which is a Mac, Apple Mac, and known as an M1 processor. So you can download the tools, the interface there, and there's also here a quick link to the quick start to get you kind of up and running. So it gives you some of the system requirements, so Windows 10 plus, Mac OS 14 plus, or Linux, Ubuntu 20 have sort of all been well kind of tested, and gives you some indication of the kind of processor that your machine would require. And these are the different packages to that you can, which I'll show you, which you can download as a bundle in one kind of click. We'll be just looking at this one here, and I think to regardless of your systems, if you've got a super fast machine, you certainly go to Stable Diffusion XL, or the Flux options, but we'll just stick with the kind of smallest model, and see what we can do with that. And it gives you an indication of how much disk space you need to download them. And so once one's downloaded and installed, and it's all very straightforward to do. If you've installed any piece of software on your computer, you'll sail through it. And I'm just going to escape from there and tuck that away a second. So I've got a few tools here. These are all the tools that we use within the CRAIL program. And so there's Ollama, which is a chatbot, which is very, very good. Just to flag that. Invoke Community Edition, Comfy UI, and also another GPT for all for generative text, another chatbot tool. But I'm just going to click on Invoke Community Edition, and what you have, you might have to install it first. So you just switch to installation mode, and that will install the software. Mine's already installed on this, and so I'm just going to launch it, and we just wait for it to install, and nice and quick. Just going to move that down and make that sort of full screen. There first up, there just a sort of this is the kind of workspace. There's a range of options running down the left-hand side. If you go to goes to the little cog right at the bottom, that's your settings. And just to flag a couple of things in the settings, there's enable not suitable for work checker, which I would slide on and switch on, and that will, so it doesn't render anything sort of shocking. And also you've got some language options here. So you do have Arabic for localization support in Invoke. So the interface kind of runs from right to left rather than the other way around. I would treat it as a partial rather than a fully polished localization, but just to show that's where you can change the language settings. And I'm just going to close that. I'll keep it in English, or I'll probably get lost. And so model installation. So if I drop down this side, and we've got that little cube, and I click on that, I've installed some models here. That's what we see just on the left. And along the top here, add a model. There's a whole range of possibilities. You might have it on the model already on your machine. you might want to use download a model from Hugging Face, but the most straightforward option is the starter models just here, and you've got these bundles running along the top. And I would recommend going for this Stable Diffusion 1.5. I've just installed, there's 19 different models within to allow full kind of control of image generation. But I'm just starting off with a couple of models, the 3 models in fact. Dream Shaper 8, which is something that's built upon Stable Diffusion version 1.5, and there's also one called Dream Shaper with in-painting, which is a sort of fine-tuned model where you can change regions of a image, and it's tailored for that case, where the Dream Shaper 8, the standard one, so you kind of flip between depending on what tasks you're doing, and I'll show you a bit of in painting what that is. The Dream Shaper 8 is just a popular versatile model, and it tries to sort of balance semi-realism with illustrative anime-ish looks. So it's kind of it has a particular flavor to it, but just to the easy thing to do is click that, and it will download. It's about 30 gigs worth of storage for all these options. So I've installed some models here. So these are for image generation. This one here is image to image, which what that means is your prompt is really an image, and it creates another image from that image. And what we use this for is for something called upscaling, which you generate a kind of low resolution image, and then you upscale it to 4 times bigger, for example. So it kind of is a model trained for that specific task of adding pixels based on context of pixels around 1 pixel, and that's how it kind of that's what it's been trained to do. So if I click on where it's got the 2 A's, that's our sort of main interface. I will just, it's got that in my way. I'm just going to move that. We've got on the right hand side something that says uncategorized, and then below it's got something called CRAIL. These things called boards are essentially folders where where your image kind of goes to. So I'm going to create a new one just by clicking that plus sign, and I'm going to just double click in there, and it's got my board, and I'm going to call it demo, and I'm going to select that. So anything I generate will go into that particular board or folder. And down this on the left hand side, we have where we type our prompts and determine what model we might use, how many steps, the guidance scale, these things which we can see down here. This is the width and height of our output. Our seed is going to be a random seed to begin with, or you can put in a number if you so wish. If one put in if we all had the same prompt, so I'm going to put in Gaussian noise. So I'm going to use that because I know that's something that the model will not be able to achieve, because it's always trying to create a coherent image from Gaussian noise. And it was one of the first things I wanted to see, what how a model would react, the tensions, I guess, the visual tensions of where it's trying to remove noise but get to noise. So so I'm interested always in the limitations of technologies. And so I put in a prompt. I really want some Gaussian noise. We have aspect ratio, so we can click on that and we can determine different aspect ratios. Well, I'm going to keep it square, and I'm going to keep the resolution 512 pixels by 512. And if we all had this loaded and all these details so far were exactly the same, and if I, for example, put 1, 2, 3, 4 as our starting seed, and then I clicked Invoke right at the top here, which is basically saying run, we would all end up with exactly the same image. So often a problem with using some of the cloud-based tools, every time you generate an image, it's another novel image and never quite what you want. And one of the reasons is to monetize these systems, so you essentially keep clicking. So just a flag that we could all type something in here and choose some parameters here of the size and choose a starting seed as the same. We would all generate exactly the same image, more or less. But I'm going to click on random, so I'll just pick something at random. I've got what model I want to use for this task. So I've got the Dream Shaper 8. But if I was doing some in-painting, I would choose in-painting, but I'm not at this stage. Concepts here, LoRa's, which are essentially small. These are things you can create yourself. They do take a little while depending on the but you're training it on your own. For example, you might be an illustrator, and it guides it uses the base model as a starting point, and then privileges your own LoRa, or so you're training like very mini models that complement the bigger model. We won't cover that today, but just a flag that. And then we've got the steps and guidance scale as well. And I sort of mentioned, if you move this up, it adheres more to your prompt. The higher you go, it will start looking peculiar. And you slide it that way. You kind of it's how much your prompt influences the output. That's essentially what that is there. I'm going to keep it at, which I would say is a sort of between 7 and 8 is a sort of sweet spot, but certainly have a play with that. And this is the amount of iterations of denoising the steps. So if I, for example, just said I just wanted one step, it wouldn't get very far. It'd be one iteration with this particular model, one iteration of removing noise. And so it would be quite an abstract image. I'm just going to slide it to, let's start off, rather than 30, 15 iterations, and we'll see how that goes. So I've made some selections here. So I've got my prompt, Gaussian noise. I've determined its size. I'm having a random seed. I've picked the model, and I've made some choices on the steps and the guidance scale as well. At the top here, we have a big button that says Invoke. It also is the same here. That will do the same thing. And I can set some batches if I wanted. It would do, I could say, I can click on that little arrow, and what it will do is the task 3 times. And so I'm going to ask it to create Gaussian noise for me 3 times. And I click Invoke, and it starts to process that. And we get a little progress here of the iterations. So it's 15 at the moment. And once it's achieved that, it will go on to the second one. And this allows you to set a little batch running overnight or something like that. So you don't have to necessarily just stay at your computer. You can set it running and go for a walk, you know, and have a think. And while it's doing that, I'm just going to show you the queue essentially, which is we can click on that, and we can see the time it took to complete that first one here. So it took about 50 seconds to do that, and about the same here. And this one is currently in progress. So we can get an idea of, often when we use the cloud-based tools, they happen in a flash. And what that is you're instructing computation elsewhere. And so this gives us a sense. Also, it opens up those conversations about the environmental impact, that things, when you're working locally, run a little slower. So, and that took 40 seconds. So I can go back here, and we can see these are its attempt to not achieve noise, Gaussian noise. So just to show you the process, if, for example, I typed in, so let's think a professor, for example. So professor, and let's see, we'll keep it on random here, and I'm just going to use that one word, and let's see the image of a professor and see what that might look like. I think we will see the usual image of what a professor looks like in terms of what is represented in this particular model. So it quickly gives us there's a privileging to white males with just attached to that particular word. Ah, excellent. An outlier in the data set. So that's the first time I've seen that with this particular model. So hooray. That's a rarity. So also we could try all sorts of different terms. We could just try from this model. If I just put in the word woman, and we could make some judgments. We could obviously have more iterations of it, but I'm just going to do another 3 just with that one word, and then I will talk, and maybe we try man as well. Quite simplistic prompts, but then how we might use a prompt to mitigate some of the biases. And I'm going to also do 3 of a man. And I will predict that most of the images will be young women. And also it might think they're not suitable for work as well. So you'll find this when you have that selected, which is just on one word, is quite telling as well. So I'm not sure it's flagging that as being a problem. It might be a false positive. And you could run that again to see with the not suitable for work in place. They didn't appear to be problematic, but I've not seen any warning signs on men, essentially, which just sort of a nod to some of the sort of sexualized content that can be found in these models. And while that's processing, I'm just going to put prompt in here for the next one. Woman, female. And so we now have these images, a couple of warning ones here, and this one here, and a very rare professor who's a woman. So I've just wrote a prompt here, woman, female, and so I have so this sort of prompting syntax is known as compel, where commas or full stops act as separators, which are quite useful to do. So I've got woman, female, Jordanian, professor in a library, and middle-aged. And you can also within that syntax, the compel syntax, you can if you add a plus, one plus, it's kind of it's like how weighted that word is. So you definitely want it to be a woman, and you add a plus. That's a sort of subtle nudge for the prompt. If you have 2 or 3 pluses before, like so, that's quite rather than a subtle, that's stronger. And if you go even higher to, let's say, 5 pluses, can start being overpowering and cause kind of artifacts. But I'm going to just in terms of that sort of prompt engineering, as they call it, that's the kind of syntax that you have at your disposal. You've also got kind of negative prompts. That little plus and minus gives you this little field to things you kind of don't want in a so it could be man, it could be text. So anything you don't want, you can type in there. And if you strongly don't want it, you could put that, for example. And so I'm not going to change anything else. I'm just going to click Invoke, and we'll see what emerges. So we have someone with three arms by the looks of things. Bear in mind, this is an older model where you had, but that also would be something you might put in the in your negative prompts. Too many fingers or something like that, which we kind of all saw as these models were emerging. And also I'm only doing 15 steps, so the kind of default for it is about 30 25 30 steps. And if I hadn't put like middle-aged, or I would put money on that most of the outputs would be very young, so young looking. So that's the general kind of process. Along the top here we have some so if I wanted to reuse, for example, so I say I wanted to reuse the prompt, and if you hover over anything in the workspace, it gives you a little rich, so I had man there, for example, so I could reuse prompts that I've already set up, and I might want to use the same seed, for example. So if I wanted exactly the same image as I've got here, if I click on that is the random noise, the seed that this image started from. So you can select on previous images that have been generated and use elements of that image to start another as a starting point for another one. And if, for example, I had two computers and filled in all these details and included that seed, it would be exactly the same image. And I'm just going to render it once and just click. And it sort of does it. It's in the cache of this, so it will do it immediately. And we've got exactly, there might be slight differences, but I can't, by clicking between the two, I don't see anything there. And so we've got that. What else would I just like to flag up? I mentioned the queues, so you can get a sense of how long things take to generate. So also along the top here, we can upscale this image. So if I just hover over here, I can see the dimensions are 512 by 512. If I click on this button here, post processing, and I click on that and process that image using that model for upscaling 4 times, I can click process, and it will upscale that image. And we would be able to look at our queue here to see how long that process took. There we go. So let's just have a look. So that took just over a minute to achieve that. And if I hover over there, it's now 2048 by 2048. So the last thing I wanted to show you, so I'm going to select one of the smaller resolutions, and I'm going to click on edit, and that takes me to this space here, and I'm going to remove the prompt that's in there at the moment. So I'm going to remove that and remove that. And what this allows you to do some masking, some inpainting within an image. So I could, for example, so you've got a brush and an eraser. So the brush allows you to brush on a mask, for example. And I'm going to do that. And maybe put a window, see what happens. And you don't have to be super accurate. So I'm just doing it like so. And this allows you to generate just a specific area that you're masking. And you can see your mask just here. And this is the the kind of reference image. So it's a mixture of image to image and text prompt. So if I type in here window, for example, and blue sky, maybe, oops, can't spell today, and we also have just on this side denoising. So if I hover over that, it's how much of the image the raster layer will influence, or the your text prompts will influence the output in this particular area. If you make a mistake, for example, I did that, we can rub it away using that. And we we have here, there are keyboard shortcuts. It's usually the square brackets on your keyboard to change the size of your brush, or you can do it just up here. You can click on that and change the size of your eraser or brush. And the other thing I'm going to unclick from a particular seed and let it be random, and I'm going to choose the other model, which is the inpainting model. And just looking at everything there, I think that we'll give it a go and see what we get. And along the bottom here, just move that out of the way. We'll get one iteration, which we kind of have to kind of confirm once it's done that. And you'll see in a moment that it will focus in not on the whole picture. That will be retained. It should, all being well, blend the two outputs together. And don't think it's been so successful there. It's not giving me a window. So I'm going to slide that up a bit more. And slide it right to the top, and let's give it another go. And click Invoke. Let's see. See how it functions.
Tim, it's Clara.
Yeah.
Are you okay to finish in the next few minutes?
Yeah, I can wrap up. Hopefully this will behave itself. And this was the last thing, and then it was just saving images, Clara.
Great, thank you.
Looks like we've got a window this time. There we go. So it really wanted to put books there in its first attempt, which was that. So just by sliding that up a little bit, and then we've got this, and we can confirm that. Just accept that change, and right at the top here, I can save that to my gallery. And I'm going to go back to here. And so we've got this image. We could upscale it, but the final thing I'm going to show you is if we go to the ... dots, we select our image, and I've got a Teams thing getting in my way. I'm going to move that down. There we go. We've got these ... dots, and just here we can click download. And then we can choose where we want to save that image. And I'm just going to do that. And lurking around should be that image, like so. And that's me done, I think, within time. So thanks. I normally do go on, but that's quite good. I should give myself a clap. Thanks for listening. If there's any, we've got 5 minutes. Or a couple of minutes. If there's any questions, I'm going to stop sharing and pop my camera on.